Ladies and gentlemen, Lightning Talks. Okay. And now for something completely different. A man with a tape recorder on his nose. So, Lightning Talks. Please sit down, tidy up. The rules of who here doesn't know the rules about Lightning Talks? Who? Okay, simple. It's 5 minutes of talk, no questions. So, I will control time, there will be a tight control on time, and it's 5 minutes. When there's 1 minute left, I will clap once, okay, like this. Easy peasy. And then, when it's 5 minutes, I will start clapping, okay, and all of you will clap with me. Okay, like it's I don't know, variety show, something like that. So let's practice, okay? When it's 1 minute left, I'm doing that. You're not doing that. Just do it, okay? Simple. And when it's 5 minutes, don't disappoint me. ¿Tienes el micro del atril? O si no. Vale, pero yo te recomiendo que uses el del atril.
Vale.
¿Vale? Okay. Ready, set, go.
Okay, hello everyone. My name is Gabriel de Maeztu, and I want to make you a really fast question. How many of you here do you usually use Jupyter in your daily basis? Hands up, please. Okay, a lot of you. So I'm quite sure that you are quite bored of having the same experience, and everybody has to experience the same font and the same colors for the text editor. So I just wanted to explore this a little bit more, and I just found that they use Code Mirror, that it's another plugin. It's a JavaScript plugin, and it's the plugin that they use in the Jupyter notebooks just to show the code and make some syntax color on it. So I started looking to the API of Code Mirror, and I found out that they have a lot of themes for the code, for the color of the code, so you can modify it as you want. So I tried to hack it a little bit. I made a very little JavaScript script. And what this script lets you is just modify this syntax. So what this makes you is to have another color in your syntax. So it's super simple, but you can use and personalize your own Jupyter to see the code in another color. So to make it as easy as possible, I just introduce everything in the cell options, and you can modify the font if you want, or modify the color. So you can put like the normal color of it, or you can put, I don't know, maybe some extreme color. And if you want to change also the font, just go, and there is like a variety of fonts that you can choose from. So the idea of this was not to hack and create like something that goes over it, but use the API that it's below and try to make it like in a cleaner way. So if you want to install it, it's super simple. Just you have to go to the Jupyter Themes repository. It's Mercurio, it's on GitHub, Mercurio Jupyter Themes, and then you just put that on your Bash console and you will get it. Right now, there is no Windows support, so if any Windows user wants to try it, please just open an issue and help us to give some support to the Windows user too. That's it. Thank you.
Thanks for the lightning talk.
Esa es la tercera, como los USB. Listo. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3
I don't want to get you nervous, but expectation is high. Yeah.
From the command line. Ha!
3, 2.
No. Where is my screen? This is going to be very fun.
Yeah. Set.
Yes.
So, 3, 2, 1, go.
Okay, I have a special place in hell reserved for those that repeat talks from time to time, but not for me because this is like the 4th or 5th or 6th time that I give this talk. But I'm trying to introduce a couple of changes. First of all, I'm going to do it live, so I don't have any results in the code right now. And I changed the trajectory, so it's going to be a little bit different. The jokes are going to be the same, so please bear with me. Okay, so this is a talk called To Mars with Python using Polyastro. In 5 minutes. So we've been talking about, were a couple of speakers saying like, this is not rocket science, this is not difficult. Well, this is rocket science, okay? What is astrodynamics in the first place? Well, astrodynamics is a branch of mechanics, which is itself a branch of physics, which studies the motion of interplanetary probes in space. For instance, I have here the plot of the Rosetta mission, which is a European mission that went to a comet with your money. And as you can see there, the trajectory was pretty involved because it was going through the Earth first, then was passing through Mars, then the Earth again, then one asteroid, then another flyby through the Earth, and then after 10 years, it arrived to the comet. So you can imagine already that this problem is pretty complex. And what is Polyastro? It's a Python library that I'm developing for studying these kind of problems. So let's go to Mars. I changed the problem, as I told you, for this talk. So I'm going to study the trajectory of the ExoMars mission that was launched like 1 month ago, and it's a joint mission with your money and Russia's money. So here's the imports that I needed first. So here we import matplotlib and very basic things about units, time, and stuff like that. And now I import everything related to Polyastro, including some files from NASA, which will tell me where are the planets exactly. First, I have to define the orbit. So I just need the position and velocity of the planet with respect to some attractor. In this case, I'm just plotting a spacecraft around the Earth, so I need the position, the velocity, and specifying that it is the Earth. So here it is. The next, I have to locate the planets. So here I specify a specific time. And using the NASA files that I told you about before, I'm able to locate the position and velocity of these planets with respect to the Sun. Third, I had to compute the trajectory. This is called like a boundary problem in this domain. And in this case, the name is the Lambert problem. So I implemented a function to solve it through a new algorithm. And here, what I get is what is the trajectory that I have from one planet to the other. The good thing is that this is pure Python, even if it's a very complex mathematical algorithm, because I managed to accelerate the whole thing with Numba. And so I managed to throw away like 10,000 lines of Fortran, and now this thing installs on Windows. So let's go to Mars already. I have to execute this function over here. And I have this little function here, which is go to Mars. And now you can see, okay, that I have this trajectory, which is exactly the trajectory from the Earth 14th March when in the future, when it arrives the 19th of October. And actually, you can see here that the trajectory is pretty strange because it's outside of the plane. And now, let's make it interactive. I don't know if you've ever seen the IPython widgets, but if you haven't, then today it's a good opportunity. Okay, here I have the same problem, but I have two variables, which are the offset in the launch time, and also a variable which controls the flight, the time of flight, which controls how fast or how slow I go to the planet. So if I move here the offset, you will see that the Earth goes forward in the orbit, okay, and also Mars and all the planets and everything. And if I put a time of flight a bit smaller, I get a shorter and shorter orbit until I have to reach the speed of light, which, of course, doesn't work. And that's all about it. Thank you very much. Uy, es verdad. No pasa nada, si podemos hacerlo otra vez. Esto.
Necesito internet, buscas light.com y es la site, ¿cómo es?
¿Cómo buscas aquí cosas?
No sé, hay
Todo tuyo.
I think.
¿Puedes usar mando? O sea, necesitas estar aquí.
Aquí lo veo un poquito raro, pero bueno. ¿Cómo con pantalla completa?
Mejor lo puedes mirar ahí, porque el
¿Cómo
ordenador
va?
no va a ir bien.
Pero como, entonces voy pasando así.
O sí, o con el mando incluso.
Okay. Yeah. Okay. So when you go?
3, 2, 1, go.
Well, this is I'm going to help because it's what Talk already delivered, but I did this in Barcelona. It was 30 minutes. So here I'm going to do in 5 minutes. It's going to be a quite different talk. It's going to be a bit scikit-learn and pandas. One of the problems with scikit-learn and pandas, why? It doesn't go down. Ah, no, what? No. Is that the scikit-learn was created before pandas was born, so scikit-learn needs numpy arrays to work with, while pandas, well, you get numpy arrays, but you get a lot of different heterogeneous types of columns, so you have to convert this pandas data frame to a numeric array to fit it to the scikit-learn models. Okay, well, this is not important. So this is a problem where you cannot use it directly, and this is bad. So, well, what we need to do is preprocessing, so you can do different kinds of preprocessing with numerical variables, with categorical variables, or and then you can use different. Scikit-learn provides you different transformers to transform these original variables into something you can fit to the scikit-learn models. But when you have heterogeneous data, it's not so easy to deal with all the variables. See, here we have an example with the Titanic dataset, which is from Kaggle, where you want to transform some of the variables. Some of them are categorical, numerical, and then here you can see the kind of variables that you have. You want to predict if people died or survived in the Titanic accident, okay? Then you want to do certain pre-processing, and you need quite a long chunk of code to do this, and this is not something desirable. I think in R you can just put a formula and get everything more or less. Well, not all the pre-processing I do here you can do it fast, but in a more Pythonic way, I would say that here in this Python. Then, well, in the transformer to do the prediction. Then what the issues there is that you have to write a lot of code, manual code to do the pre-processing, and it's hard to read, and also you cannot integrate it right with pipelines. So one of the packets I use every day in my job is scikit-learn pandas, which is a kind of bridge to convert these pandas data frames to numpy arrays to fit to the models. Well, it was created by a guy from Kaggle and maintained with people from Google, and now I'm maintaining it, so it's good. And then the syntax is much like I think it's more or less syntax sugar, because in the end you are applying the same code, the things that are working the same, but I think the syntax is much more easy. It's easier to read. So it's you define, instead of having to write all the code, you just define the column you want to transform and the transformers you want to apply to them. Okay, more or less like that. And then it works. You can put this into a pipeline, so you can put the data frame mapper, what is called before, and then the classifier, and everything works well. And you can use it also this inside a cross validation, or also with a grid search. Okay. And the final words is that, well, in my opinion, I think that the scikit-learn transformers, they're still thought to work with numerical arrays and not with, for example, like string-based variables where you have categories and some of the things that are not very easy to use. Then I think they have to improve. And also I learned that for some tools, I started using this, and I think that, and then I become the maintainer. What I think is, for many packages, even you think that people that work on free software are superheroes, you can also contribute to free software, and it's not so hard. But the problem is that if you are maintaining a package for that a lot of people use, you have to be careful, of course. That's with great power comes great responsibility. And some of the things I want to do with this circular pandas package is to do like parallelized transformation, because nowadays they are doing a serial fashion. While the rest of them is not so important. So I think that's all. Thank you.
Va sin mando, ¿no?
Sí. Oh, wow. Beautiful. Okay. That's how it's going to work.
That's how it is? Okay, so ready?
Yeah.
Set?
So, PyBikes. How many bike sharing users are out here in this room? Okay, I feel so. At least you know what it is. 6 years ago, I wanted to use the local bike sharing system in Barcelona and realized that their website was a pain to use, and somehow I wanted to access it better. So I learned the wonders of scraping as a whole. So I released OpenBising, which was an Android app that was for accessing bike sharing information in Barcelona. And I did the same in Paris, then in London and blah, blah. Then I did something called City Bikes, which is the same project but aggregating information for the whole world. So basically what started just here ended up as a library that supports more than 400 different cities in all the world. And we can see that if I get a browser, oh yeah, here. So this is a map of the current coverage, and I don't know if you can see it, but all these splashes are real-time usage of bike sharing in different cities. So for instance, I can look for Barcelona, and we can see some people using there. So somebody left a bicycle there, that's somebody taking a bicycle, and so on. And by now you might wonder why Madrid is not here. And Madrid is not here basically because they don't have this data set open, and their website has an image instead of an interactive map, basically because they want to avoid being scraped. Well, another thing we can see, since this presentation started roughly, 400 bicycles have been taken and 400 have been left. And so PyBikes, which was actually what I wanted to talk you about, how easy it is to use this library. This is not using any kind of API. I mean, we have an API on the project that you can use, but of course you also have the Python library where you can add your own city. So basically this is a program that will give you the stations that are around you if you pass an address, like, I don't know, we can look for any address here. And it will give you the 5 nearest stations that are around you. And all this not using the API, but using this Python library. So if you are interested, just please go to the repository, add your own city, fix bugs, whatever. And because I have some more time, it looks like, by now you might be wondering why I worry that much about bicycles. I mean, it's can get a pretty boring, but I discovered this. This is called public-private partnerships, which is what happens when you let private companies run public projects, which is they kidnap this public information and make it their own. So the city council is forced to pay to these companies to make them an Android app using their information. So what we want to say on all this open data, smart city, Kool-Aid stuff, it's if you want open data, just open it, go for it, instead of just creating hackathons and congresses and stuff. And if you wonder about the Android app I started, we are not working on that anymore because we realized that doing the Open API or PyBakes was way important than just doing an Android app, because information is way superior to just representations, because representations are just a poor interpretation of data. And well, this is the end, yeah.
Se ha creado una... Estoy usando esto, sí. Voy a usar PowerPoint porque soy antiguo, lo siento.
So attention, ready, set, go.
Okay, so I'm going to try to explain very quickly what is a genetic algorithm. Genetic algorithms are based on the natural evolution, which are a process that optimize living things during time through natural selection, like killing the less fit animals or whatever, and reproducing the most fit creatures. With genetic algorithms, we will try to do something like that, but with solutions to a problem. For example, I want to optimize the problem of an airfoil, which is like flying in the wind, and I want to optimize wherever, for example, the aerodynamic drag or anything. So our population will be made of individuals which have to be described by a series of parameters, which must be the same parameter for every individual, because we have to compare each individual with the others. So, for example, we can describe an airfoil with a series of points, which are then joined with, for example, a Bezier curve or whatever. So this is an example of how can we describe an airfoil. So we can generate a certain airfoil with this kind of curves, and we only need like 16 parameters, which are numbers. So these numbers can be coded in binary, making like a DNA, but instead of being made of chemicals, are made of bits. So the first step, we will have to transcript the genetic code into the values of these traits. Then the traits, which are, for example, the geometrical points of the airfoil, have to be executed, have to be analyzed in order to get like the performances. This is the step, which is the typical problem we want to optimize. In this case, we will have an aerodynamic program which will analyze the airfoil and get the aerodynamic forces or whatever. And then the last step is get a final fitness function, which will compress everything, every performance into a single number. Okay, the fitness function is the most important function in the whole algorithm, and is where you have to focus in order to get a proper working algorithm. So every loop is called a generation, because it's like a generation of animals or person or whatever. And we start with a population, then we analyze the population, we select and kill people, and then we reproduce the survivors in order to get a new population. Okay, the selection can be selecting the most fit, or it can be random. And okay, we have to make an equilibrium between how many people we kill and how many people survive in order to not lose a lot of information, but at the same time get room for new people. And reproduction will get a new population from the survivors. We can as well depend the reproduction on the fitness or make it random. If you make random both processes, we will not get evolution. We have to make at least one of the two, depending on the fitness of the population. There are two steps in reproduction. First, with cross, we will mix the DNA of two parents in order to get a child. And then the mutation will change small bits of the child in order to get new individuals which are not exactly like their parents. So we will explore new areas of the solution space of our problem. For opening the algorithm, typically we can generate random strings of ones and zeros in order to get our genomes. And for stopping criteria, we can use a fixed number of generations or just check if our solution is stable. With Python, we can do it easily just by hand using objects, but we also have a very nice library called DEAP, which will happen to appear if you Google genetic algorithm Python. So that's all. I hope you at least get some interest in this kind of algorithm because they are very fun to use. Thank you.
Tengo preguntas de...
Ah, vale. Un segundo.
Ready? Okay, ready, set, go.
Hello, my name is Javier Martin, and I work at CartoDB. I'm the metrics guy. So this talk comes from a colleague from the sales team that came the other day to me and said to me, hi, we need to know where our customers are located. Okay, great. We do maps. Let's do a map. No, but we need to have a dashboard, not a map. We need to have this map updated as the as the data is updated. This is a little more complicated, but after doing, I realized that it's not so complicated. In fact, it's really easy. It's not rocket science at all. So the challenge here is, can I do it in 5 minutes? So let's try. This is the scenario. We have an initial file with all our customer information. This file is in G Drive, and it comes from an external application. Each row of this file has metadata for the customer and also the payment he has done in the previous month. Okay, what we are going to do is we are going to take this file from G Drive. We are going to enrich this file with new attributes. We want, for example, to know what is the behavior of the customer in the last month, if he's a new customer, if he has churned, if he has canceled his subscriptions, and another things. In this demo, we are going only to calculate this. We are going to upload this file to Google Drive, and we are going to create. We are going to import this file into CartoDB, where we have another table with the addresses of our customer. This is something that is more or less stable. We can update with new customer, but it doesn't change. And this address, this table has the position of the customers. We are joined to both tables, and we are showing them up. That's all. So let's do it. You can find all the code in GitHub if you're interested to replicate it. So we are run all the cells. to gain some time. Here we have a simple class to upload, to download and to update an existing file in G Drive. So here we are downloading the file, and we are creating a data frame in Pandas with it. It looks like something like this. We have an account ID for each customer, the name, email, where he created the account, the current plan, and the payments in the prior months. Here, we are cleaning this data set. We are removing not useful columns, and we are taking care of non-available values. Here, we enrich the data frame. It's really easy with the apply method. So we are identifying the behavior of each customer in each row, and we are calculating the difference between the prior month and the current month. Okay? This is the resulting, and oh, I have no time at all. Okay, we are going to import the file. We are going to synchronize this file. Okay. So the tricky part is we are going to use a view, not a table. Here are our customers, and we want to show them by behavior. So new ones are green, and the one who has canceled the subscription are in light blue. And we also want to get some information from them. So we can share this map, just publish, with these options. We can share the link or just get this iframe and embed it in the website. So that's all.
Ready? Set? Go.
Okay, this is the second time I'm in a PyData, and I feel that it should be a bokeh talk. I think it's a pretty cool library. I really love it, and it wasn't one there. So I just decided to take my charts, all my plots from the previous talk, put them together, and pretend this is a proper lightning talk about bokeh. Let's see what we can do. First, I'll just get some data. There is nothing tricky. If you don't know, just want to question before I start. How many people knows bokeh? Has used it? Okay, most of you. How many people is using mostly bokeh instead of matplotlib or? Okay, so not so many people excited as me. Let's see why. Okay, so well, the first thing, if you used it in Notebook, probably you already know. You need to just run some command to make them show on the notebook. And then you just import it. Then creating a figure is as easy as this is. And then what really, I mean, it's been some comments already regarding Bucket and how this architecture and having the JavaScript that it's all done and we just take care of sending the right JSON from Python, that it's basically how it works, how cool this is. I totally agree, but it's not really what it excites me. I mean, I haven't had the opportunity to build like a fancy dashboard with Bucket that gets updated with WebSockets, all that. What I really like, it's somehow mind-blowing at the beginning, but instead, the first time I was using it, I was really disappointed. It was like, fuck, I want to just write a bar plot. Why is not a bar plot in Bokeh? It's like, what kind of plots are they thinking on? So it was really disappointing. I don't know if this is the reason so few people really use it here. But after using it a couple of times, giving a second try, I found that just being able to draw is like, it's not a plotting library, it's just like Matplotlib that you can create a bar plot, a histogram or whatever. It's just like, you just draw things. I found it so amazing. So at here, I just want to draw circles. This is a scatter plot. Bokeh doesn't know anything about the scatter plot. So I just take my data and I say, okay, this is like the X, the Y, the color I want. So I basically get this plot. It's like half of the data of an example I used before. Then I can add the other half of it, the other class. They are here. Then I want to use a histogram. Bokeh, as I said, doesn't know anything about histograms or any kind of chart, so I do it with NumPy. NumPy provides a quite easy way. I get the histogram, that it's basically the size of the histogram that adds up to 1 for all the possible bins, and the edge is like where they are placed. So I just get this information from NumPy. And again, as I'm just plotting, I'll be plotting just the squares this time instead of circles. Bokeh still doesn't know anything, and I think, I'm not sure, I'm not a big expert of Matplotlib, but I think it's not that easy just to start mixing scatter plots with bar charts in Matplotlib or with histograms. In Bokeh, as you've seen, is like, he's perfectly happy with that. So let's go a little bit more to the extent that this talk doesn't make that much sense, but I want to plot some lines. Basically, I'm plotting the lines of the average distance for each age. Don't try to find a meaning on that. It's like, I don't know, I just wanted to draw more stuff on this plot. It looks pretty cool, and actually I was guessing when I wrote here purple, if it was really gonna be color purple. It was, so it was like kind of surprising. There's also something pretty cool I just discovered. You can also have images on that. So you can just get a cat that is amazed as me about Bokeh. I don't know, and well, I think I'll just skip. I won't have time. I wanted to explain how I made the charts for the cards. I'll just start, but I won't have time to finish. I just want to show you this. It's not that related to Bokeh, but scikit-learn just provides arrays, different arrays for the parameters of the card for each node. So it has one array for the feature it represents, one array for the threshold, one array to define the child and everything. And well, just something that makes me really feel in love with Python. It's like, this thing over here just puts all them together. It creates a name tuple, kind of an object. It zips over them. It's using like star maps. I don't know. At the end, I just have independent arrays of that. And at the end, I cannot show you. What I get is just a list of nodes where each node is a name tuple. So I can just write things. It should be here, and I'm done with it. It's like, yeah, you can. I don't find it now, but yeah, never mind. Well, you know what's a name tuple. You can just access that, so it's really convenient. Just like, I don't know, I really love how Python just lets you put 4 arrays together in a list of nodes with a really fancy interface as getting the attributes. So that's it.
So without further ado, see you tomorrow.